Welcome everyone, and thank you for joining today. So I'm going to leave the link to the slides. You can scan them if you want to follow along from your device or for future reference or whatever. My name is Konstantinos Papadopoulos. I'm an electrical and computer engineer from, you guessed it, from Greece. And for the past 5 years, I've been working as a software engineer and doing some stuff with open source, one of them being the maintainer of our stuff, an OpenSSF project, and some other smaller personal projects. So a few years back, one of my friends sent me this quite popular meme, the number one legitimate reason for programmers to slack off compiling. To which I replied something like, I guess then we Python devs don't slack off. I lied. Turns out we too can slack off, and that's testing. So jokes aside, having worked with a few code bases with hundreds or thousands of tests, there are cases where the time for the test to complete is can become counterproductive. So let's see a bit more why that can be. So a typical developer workflow looks something like this. You write some tests and then that fail, and then you try to write some code to make your test pass, or the other way around, depending on the school of testing you're from. So after you've got your code running, you want to check that it plays well along the rest of your code. So you run some integration tests. You find some bugs, you fix them, you run your internal tests again, you run your integration tests, and you repeat those cycles until you have everything running. And when you're finally ready, you can give your code for the valuable peer review, get 50 comments back, and repeat the cycle again. So you can understand that the more time the tests take to complete, the easier it is to get out of your zone, and this could actually mean fewer code feedback cycles. Another important thing is the mean time to repair. So a typical continuous integration and continuous deployment pipeline looks something like this. So after you build and before you push to staging or production your code, you usually want to test it. So when that critical bug comes out and you want your fix as soon as possible, this could mean more time to get the correct code out there. Of course, you could bypass the tests, but eventually at some point you would be adding another bug. So highly not advised to do so. And of course, with most CI/CD pipelines running on the cloud nowadays, longer test times could mean a higher bill at the end of the day. So back to today. What I want to show you today is some simple and quick methods, meaning not very intrusive methods, not rewriting your whole test suite necessarily, to tackle the problem with your test taking too long. We're going to be speaking about a step after measuring. So of course, most of us work in a business environment where we cannot just go and over-optimize everything, but this is some methods you can quickly apply when you've noticed that there is a problem for the reasons mentioned before or for some other reason. And I'm mainly going to be using PyTest in my examples, but the general principles can be applied in any framework or library. By the way, all the examples have a link at the end, so you can find them. So let's talk about fixtures. In general, fixtures in software testing are entities that can be used to mock or easily reuse data in our tests. In PyTest, having a fixture is as simple as decorating your function with the PyTest fixture decorator. So in this simple example, very simplistic one, that we test the add function, instead of passing the numbers we want to test every time, we just pass the fixture as an argument to our functions. That's great. Now let's see a more realistic scenario. As I mentioned, we use fixtures in places where we do repetitive work, at least one of those use cases. So let's say we want to test reading and writing to a table on our database. We always want to connect first to the database. So what we can do with PyTest is define a fixture again, as I mentioned, that first sets sets up a mock session. I've added a delay of 2 seconds just to simulate that setting up. And also on the right, you can see I have a typical life cycle of a test. So that means that before the test runs, this fixture will load, set up the database when it's being passed as an argument. And after that, it will also tear down the database, which can also take some time. So if we run this dummy test, it will take about 4 seconds, because by default, fixtures in PyTest and are created every time we use the function. So 2 times the simulated delay and 2 tests is the 4 seconds you see. So what is very important is to start thinking the scope of our fixtures. So if we have a test like this one, where writing to the database doesn't affect the tests, we can simply define a different scope for our fixture, basically caching our fixture in the context of, in this case, the module. So when I run the test now, it'll only take 2 seconds, since the scope is not destroyed at the end of each call of the functions. There are also other scopes that you can use in PyTest, like the function scope, or if you're using classes, you can define a class, or even whole session, depending on your test. Let's see another method, actually one that might be one of the quickest wins when you have a very slow test suite, and that's distributed CPU testing. To set you up a bit with our example, we just create a dummy delay of 2 seconds for our test. It's tests that just 11 tests actually that just pass, and 1 extra test just to make it a 12 even test. So we have 12 tests with a 2 seconds delay. If we went and ran that with PyTest, just simply PyTest and running those tests, it will take about 24 seconds, right? We have 12 tests and 2 seconds delay. So what PyTest does is goes over each test and runs them sequentially. If you also see the processes related to PyTest in your machine, you will only notice one PyTest process. So having, especially nowadays, modern machines with multiple cores or that support hyperthreading, we can take advantage of that and have a setup like this one, where we have a controller and we distribute the tests into different workers inside our own, inside the same machine. One way to do this is with the PyTest XTest plugin. So first of all, PyTest plugins are basically packages that extend functionalities of PyTest. Some of them are created by PyTest. You can create your own. There's quite a big community and variety of plugins you can use. So going back to our example, using PyTest XTest, you can call it as seen on the screen. You can say PyTest minus n auto, which means use the same number of workers as the physical cores on your machine. So my machine has 6 cores, and it will spawn 6 workers, and what took before about 24 seconds now takes about 5 seconds. Just to verify, yeah, I have 1 core, and you can see now that on the top there are 6 processes created from PyTest, and a 7th one, which is actually the controller. But you can also take advantage of this on your CI. I use GitHub Actions here, but yeah, you can typically do it in any CI. So you can see that your one standard runner has 1 core here, but 2 threads. So instead of using the number of physical cores, you can actually use the number of logical cores and use PyTest XTest again. So yeah, in this example, again, 25 seconds if we just run with a single CPU, and we just use the extra thread here, we cut it down. We use 2 workers and cut it down in half. And another nice little neat trick I like to do is, especially when working on monorepos and you have a set of tests that you always want to run by your team, or you're working on a new feature, I use Git hooks. So Git hooks are scripts that you can run before specific stages of Git, like before pushing or before committing. And specifically here, I use the pre-commit tool, and you can specify that you want to run a subset of your test with XTest, so it will run much faster. Here's a small example. So before committing, maybe it's even more practical. Before pushing your code and loading those failures to the CI, you can just test them locally first. To conclude with this method, this is generally great with unit tests, which are usually isolated tests. You're not changing the state of a database or another service outside. It's very good for running on your device, as I showed, but you can also take advantage of it on CI. And some things you might want to consider is what we talked about, the fixtures before and the scope. They will not run by default. You might be losing some of those advantages. And you also need to think of the working distribution. Before, we just showed a simple equally distributed scenario, and that uses round robin, but there are a lot of other options you can use. Some other caveats that are related to specifically to this plugin that I showed is that you cannot use the PDB debugger, and standard output and standard error from the workers is not visible while you're running the test. And last but not least, the order and amount of tests should be consistent throughout your tests. So if the last condition is not met, you might need to change a few things before you apply using PyTest XTest. So we talked about using maybe cores or threads in your own machine, but you can also do some horizontal scaling. So similarly to before, you can split your tests into different groups and use a distributor to fan those tests out into different machines. This is great for integration tests and end-to-end tests, which might have a bigger load on your machine and might be changing the state of different services, again, like a database. It's very good for running on your CI because you can spawn multiple machines, and you can also get quicker feedback. So one of the set of tests fails, you can already start working on it. And so we're going to see how to use that using the PyTest plugin, PyTest Split plugin, which is another plugin of PyTest. We can use markers, and basically you can use any other strategy you want to decide how to split your tests in different machines. So using the plugin I mentioned, it's as simple as defining the number of splits, so the number of different machines you want to use, and running them by group. There are two main algorithms you can use to do the splitting. One keeps the absolute order of the tests and uses a duration-based chunk. So basically the algorithm just finds the optimal spot in which to put the boundaries and split the tests. And something that's usually more performant is using the least durations algorithm, where the relative order is maintained. So test 4 is after test 1, test 5 is after test 2, and so on. But basically the algorithm in this case goes by each test one by one and puts it in the chunk in the worker with the least amount of testing duration. So yeah, you might ask how we know the duration of each of the tests. The plugin assumes an average testing execution, but you can also store them periodically using the PyTest store durations parameter. So you can have some statistics and you can distribute your tests a bit better. Again, an example on CI on how to use that. You can use the matrix strategy, set your number of PyTest groups, and just as one of the steps, use that parameter to run with PyTest splits your specific test group. To show you the truth, using three workers here instead of 24 seconds that we had in the beginning that we ran the test sequentially. Now we have about 9 seconds per worker, of course. But again, we have the advantages of quicker feedback and our tests passing faster. So as I mentioned, we can also use PyTest markers. This is basically just a decorator on top of your tests. You can define them however you want. You can say that I have some fast unit tests or some fast end-to-end tests or some slow end-to-end tests. This is just to split your tests into different queues, let's say, and not have them waiting for some slow tests. Again, it helps with getting quicker feedback, and you can just run it as displayed on the screen with the marker. Now, we talked a lot about the test phase, but just one step before is usually the setup, especially in when running on your CI. Every time your setup is a clean slate. So caching some of those dependencies is great, especially if you have large builds and builds that are very frequent. And you also, if you want to work in an environment that you want to minimize network calls. Let's see another example how you can do that with GitHub Actions. In this case, the setup Python action, a very popular action, has by default a pip cache option. Basically, it checks every time if the requirements.txt file or the PyProject TOML file has changed. And if it does not, it uses the cache. Otherwise, it's in the hash and it creates a new cache. There's similar actions for Poetry and other tools. I think also for pipend. So this is just an example with pip. So in the first scenario here, the cache is not found when we run the setup. But if we run it again and we don't change the requirements or the PyProject.toml file, you see that the cache has been restored. The difference here is pretty small. Like the first one was 7 seconds, the second one is 5. But the bigger your builds are, you're going to see a bigger difference, of course. So in the interest of time, I did not have a full-blown example here, but you can also find it in the link. But a lot of us use containerized applications. So another great thing you can do is use Docker's layer caching and just cast the layers at the right spot. Because of course we don't only use Python dependencies, but you might use Node, or you're setting up and downloading your database is something that also takes quite a load on your test suite. So here you see it takes about 2.3 minutes to build for the first time. And using the cache, it takes half the time in this very simple example. Now, one last thing. I promised I wasn't going to show very intrusive methods, but this is something really interesting I first read about in a great book called Architecture Patterns with Python, and is differentiating what to test versus how to test it. I'm going to set you up again with a small example. Let's say we have a very simple client application, which we send some messages. A text message that's simply a string, and a picture message with a string and a URL. So we want to send some messages, and let's say if it's a Monday, we send a picture message with some text. If it's a Friday, we send another picture message with relevant text. And if it's any other boring day, we just send a text message. And I added, again, a simple delay of 1 second to simulate some network delay. So this is what we want to test. This is our code. We want to test that we send the messages correctly. One way to do it without introducing any abstractions yet, I give away what the solution might be, but is to go for every day, and test that for Monday, we send the message correctly, maybe have the appropriate response. The same thing for Friday, and for testing for a random day. So we're making 3 different network calls to test our send message function. This, of course, is going to take 3 seconds because we added this fake delay. What we can do now is shift our thinking into how we want to test. So what we really want to know is that we send the right type of message. On the left, you see the code that I showed before, and on the right is using abstractions. So instead of using send message directly, we can delegate the logic to another function, the create message one. And we say that if it's a Monday, create and return a picture type of message. If it's a Friday, the relevant one. And of course, ending with a text message. So now send message can use this to create the right message and then communicate with the third-party service that actually does the networking call and actually sends a message. With this abstraction here on the right, we can now do a bit of a different type of testing. We can shift into a unit test. So we can test that the Monday message is correct by just using the day and expecting the type of message that we want, the picture methods class. And if we want to be in sake of completeness, you might also want to have just a few integration tests to see that your client actually works. So this will take much less time since we're shifting to a unit test and we're not actually communicating to any third-party service. Some other common gotchas is, of course, also in your production code, but in tests as well, is use timeouts in your requests because they might be hanging and your test might be taking more time to complete and they're just repeating your requests. Retry with caution. And on a similar note, on production, you might have a specific retry logic that you might not want necessarily in tests if you want them to fake a bit more quickly, even though that might be a bit of flakiness. So you can use environment variables to see where you're running and adapt your logic accordingly. Again, something similar to retry is the sleep calls that in testing could take some time just being idle. For some things that in production might make sense, it might not make sense in testing. And nice little tip is also using the max fail parameter, so you can get, again, quicker results. So if you have 25 tests failing, you don't need to wait for the 26 to start working on them. But I've kept the best method for last, and that is you cannot have a slow test suite if you don't have any tests. Just kidding. Thank you.